We will move to Iowa State University. We have two presentations. Both Dr. Justin DAHLBERG is going to do that for us. The first project Dr. DAHLBERG is presenting is investigation of the efficacy of helical pile foundation implementation in accelerated bridge construction project. And this will be part 2 of the project that Dr. DAHLBERG did in last cycle. Dr. DAHLBERG?
Great. Yeah, thanks for the introduction. As you mentioned, I'll be talking today about a project that we've not yet started, but should be starting here in the next month or two. It's the second phase of the investigation of the efficacy of helical pile foundation implementation in accelerated bridge construction. It's a long-winded way of saying we're looking at helical piles and how we can use them on accelerated bridge construction projects. This phase 2 is really moving into the implementation phase, whereas phase 1 was really researching the efficacy of is it a viable option or not. Okay, so just some real quick background. You know, we're all familiar with accelerated bridge construction projects, all the advances that have been made really over the last 10 plus years. But what we do know about those projects is that many have been focused on bridge decks and superstructures, and really to a lesser extent, substructures. That being said, we have an opportunity to advance substructure construction and expedite that using new technologies, or in this case, a technology that exists but is used in primarily in other industries. So in phase 1, as I said, we really set out to identify the value of using helical piles for ABC projects. If you're not at all familiar with helical piles, there's a photograph there on the right that is the lead section of these piles, and really the way they act is they're simply screwed into the ground, and the pile, the loads on the piles are transferred to the subsurface through the helices primarily, in addition to some element of skin friction. What's shown here again is the lead section, and there's simply extensions added on as they're inserted into the ground. They have a surprisingly high capacity for something as simple as what's seen here, and as small as what's seen here, in fact. Some of the advantages of the helical piles, and really why it's attractive to accelerated bridge construction. First is its speed of installation. Secondly, the ability to work within areas of limited space. So as you can imagine, say a bridge that's in service and a substructure, there's an option to install a substructure prior to the existing bridge going out of service. You can get smaller equipment under this bridge and work within that space. As I mentioned, the equipment that's required to install the helical piles is often you know, no bigger than a small backhoe or even a skid loader. These piles can be installed in really many soil strata types. Really, the only limiting factor is if you have a lot of cobbles, rocks, or in fact if there's bedrock near the surface. Very little ground preparation is required prior to installation. And one big advantage of these piles is that the capacity is known immediately upon completion of installation. This is done through a torque head on the machinery, and so there's a direct correlation to the torque that's needed to install the piles. And then once they are installed, there's no wait period. You can simply construct immediately right after the completion of installation. So in phase 1, we had an opportunity to participate in a demonstration or view the installation of several of these piles. A couple things I'll point out is first, the size of the equipment required in this case was just a small backhoe. The crew that's required to install these is really small in size. You're actually seeing more guys in this picture than were actually in the crew. There was some other ongoing work on site here as well. So the crew really was the equipment operator and then a spotter out at the pile itself. Just an additional photograph of installation taking place. Again, it's a small excavator. Once the pile is pile installation is first initiated, it's really quite simple after that. It's just simply screwing into the ground, adding extensions as is required to meet capacity. The piles that were being installed here ended up being approximately, there's about 75 to 80 feet in total length, and the capacity was about 80 kips. So you can imagine for a bridge with several of these piles, most often on a typical bridge, the capacity is going to be sufficient for the load demands. Just a closer up shot of the hydraulic torque head that just simply slides over the top of the helical pile and advances that pile into the ground. And then one final shot of installation taking place here. Okay, so for phase 2, like I said, we're going to be starting here shortly. Our research scope is as follows. We'll continue a literature review of helical pile systems beyond what was included in the phase 1, and I'm sure not a lot of information has come out since we first published our document in the spring, but it's good to circle back and make sure that there isn't additional information that would be beneficial to this phase. Secondly, is we're going to be developing a design guide for helical pile use on bridge projects. And this is where a bulk of our efforts are going to lie. Within this design guide, we anticipate there'll be numerous sections, including just a general overview, a preliminary design section, loads and load application, analysis and design of the piles, detailing, what are the connections to the bridge abutment or pier is going to look like. And then finally, we'll include a section on contracting. Once we've completed that, we're going to set out to identify a bridge project for demonstration. We've already been talking with our state DOT here in Iowa, as well as some of the county engineers, and there's interest in pursuing a demonstration project. Once we've identified that project, we're going to be collaborating with the design engineers to establish plans and specifications for that project. And then finally, we're going to be providing just a summary of our findings in phase 2, along with recommendations for phase 3, which would be the observation of construction of the previously identified demonstration project. So just some final comments before I wrap up this presentation. I want to point out again that helical piles have historically been used in non-bridge applications. A lot of them are used in the vertical construction industry, oil and gas, but there's been very few bridge applications to date. So I want to emphasize it's not a new technology per se. It's just new to the bridge industry. And then lastly, using helical piles, their simplicity, their ease of installation, they do provide an opportunity to expedite deep foundation construction on bridge structures. So we're looking forward to starting the project. Like I said, we've seen a lot of interest here in the state of Iowa, and I'm sure the application will certainly be beyond our state lines. with that, I'll wrap up this presentation. Can answer any questions at this time if time allows. And then I think I've got another presentation following this. We may need to wait till the allotted time to start that, I believe.
Yes. Thank you, Dr. Dahlberg. Again, I remember from your last presentation, I still have a question in my mind that what kind of soils, what kind of ground we need for this helical shafts to work with.
Sure. Yeah. So it's probably better answered as to what kind of soil wouldn't it work in, because the piles themselves can be designed for clays, sands. I mean, you name it. It's really wide ranging. Really where helical piles don't work is in soils that are especially rocky or full of cobbles. It just it limits the advancement of the pile into the ground, or where there's near surface bedrock. And in that case, it just doesn't make sense to use this kind of foundation for that location. There's certainly better options, but we've in our phase 1 we investigated that. We wanted to make sure we weren't limiting ourselves to a single soil strata type. And what we've discovered in talking with industry experts is they're really wide ranging and widely applicable.
And what dimensions you said up to this will go as of I guess dimension compared to capacity, whichever you're more comfortable to put a limit on the helical shaft.
I'm sorry, Armin, I caught about half of what you just said there.
Oh, sorry. So what I was saying that either through dimension or capacity, what would be the limit of this helical shaft?
It's going to be likely capacity first, but what I didn't point out here, and I should have, is that the helical piles themselves come in a lot of different sizes, right? So you're going to be pairing the size of helical pile to your soil conditions and the required capacity. What was shown in these photographs, it was a 2-inch solid bar with a 6, 8, and a 12-inch helice at the end of those. They do come in larger square shapes as well as cylindrical. So what I showed there is simply one of many products that exist within the helical pile technology.
And that one, what capacity you expect?
Yeah, the capacity on that one is it was about 80 kips. And the soil strata that was being installed was primarily clay with some sand seams. And you're going to have a soil boring first to really design the pile well, but that's not unlike any other foundation type.
Sure. And I guess I'm personally interested because it's a helical shaft looks to me the answers to a lot of questions. So that's why I have so many questions on it. What about inclined? Did you mention in your presentation about inclined shaft?
Yep. So for any kind of lateral load application, you can batter these very simply, and you're going to take lateral load through a battered pile. I mean, there is some lateral resistance inherently with just a vertical installation, but any place where you're going to be seeing significant lateral loads, it's typically carried through the battered piles.
Okay, and again, something that I would question as soon as somebody said I designed the helical shaft is that what will happen to the end of the shaft? How is it gonna be similar to a pile? How would you tie the end of the shaft?
Where you're connecting to the abutment structure, as an example.
Exactly. Yes.
Yep. So it's not too dissimilar than what we're seeing on say other accelerated bridge construction projects, where it could be sleeved into say a CMP. I mean, there's probably some additional detailing or a connector plate at the top of the pile, which would be very easy installation, right? It's already fabricated such that you can couple additional pile lengths to it. It'd just be now you're coupling a fabricated plate to the top of that.
I see. And probably that embedded in concrete or
correct.
Something like that. Okay.